Hello, AP Statistics, and welcome to your Chapter 3 multiple choice review video. I'm going to go through 10 multiple choice questions today and just kind of go through the way that we would answer them. So, without further ado, let's get to it. Let's go ahead and take a moment to read over the problem. All right, so we'd like to know, what do you think the relationship between a morning blood pressure and an evening, or I guess an afternoon blood pressure would be? All right, so let's go through the answers and select the best one. So would the correlation be near zero? Do you think that afternoon readings would be independent? No way, right? Their blood pressure is not going to fluctuate so much in just a few hours. Not without medication. So let's see. Would the correlation be high and positive? So those with relatively high readings in the morning will tend to have a relatively high reading in the afternoon. I'm going to hang on to that. Sounds right, but I'm going to make sure there's not a better answer. So high and negative, those with the relatively high readings in the morning will tend to have relatively low readings. There's no way, right? That's not true. Near zero, as correlation measures the strength of linear association. I mean, I would say that possibly that's a linear association. I'm going to take that one out. Near zero, I mean, I don't think that any of these, the correlation would be zero at all, right? You should have a fairly high correlation with blood pressure because of the idea that it's not going to fluctuate that much just because of time of the day. So we're going to go ahead and stick with B. Excellent. Let's go on to the next one. So if some bivariate data, it's got a correlation, a high positive correlation, and then we've got another one that's got a low negative or a high negative correlation, right? Sorry. Then what we would say, a linear model has a better job of describing the relationship between variables in data set A than data set B. No, I mean, if you've got that high of a correlation, whether it's negative or positive, it's showing that the data should be following a linear model. So both of them, right? I should follow a linear model. Okay, a linear model is better, but like again, I don't think that a linear model is going to do a better job on one than the other. I do like this. Can't tell whether either data set is best until you examine the scatter plots. Let's look into that answer a little more. And then of course R can be negative, right? Because we know that R is a value between -1 and 1, right? So that's all well and good. Now we have to decide. I mean, is it possible that the data is nonlinear and has such a correlation, right? Because if that's true, then we would choose D. If that's not true, then we'll choose C. So let's kind of look at what something like that would look like. So that's the way I do things. I like to make a real example. Is there a real example of something that is non-linear but has a really high correlation? I think that might. And that is not looking linear. So then I think it is the case that there's a chance that the data could be nonlinear and have a high correlation, which means that I'm actually going to take out C and I'm going to go ahead and choose D. All right, let's move on to the next one. Oh, you don't need that anymore. Okay. So we've got a least squares regression line, right, where this is our y hat, our predicted, right, and there's our x. That is our explanatory or Yeah, our explanatory variable. What are we going to say is false? All right. It is estimated that for every additional gram of fat in the cereal, the number of calories increases by about 10. Hmm. Every additional gram of fat. Well, hang on to that one, all right? Um, we want what's false. So that is true. Fantastic. Sorry, I'm looking at, I have a tendency to do that. I look for things that are true. Um, we're actually looking for the one that's false. And they underline it for me too. But hey, that didn't stop me from trying to do it wrong. Here we go. All right. It's estimated that in cereals with no fat, the total amount of calories is about 97. And that's going to be true as well because if we let fat equal 0, right, then all we're going to have left is this y-intercept. So that's also true. If a cereal has 2 grams of fat, then it is estimated that the total number of calories is about 11. So what we would have to do is substitute 2 in here and see if indeed we get something around 11. So we'll get out the calculator and punch it in. And it looks like that one is true as well. If you go ahead and calculate, 97.1053 plus this quantity, right? We're going to make sure to multiply by 2. So that one's true. The correlation is positive. Definitely. How do we know that the correlation is positive? We know because our slope is positive. So our correlation must be positive. And then, we'll check and make sure. I'm not just going to circle it because it's the last one. I want to make sure that this bad boy is false. So if one cereal has 140 calories and 5 grams of fat, its residual is about 5 calories. I'm going to go ahead and work it out just to be sure. You can never be too sure. So let's go ahead and see what our predicted value would be for 5 grams of fat. And actually, we've already worked that out, right? And no, we did not work that out yet. Sorry. We did this one that had 116. I think I kept saying 11. 116. Don't know why I decided to leave the 6 off. But no, we haven't worked that out, right? We worked it out for 2 grams of fat. We have not worked it out for the 5 grams of fat. So this is going to look like this. We're going to have the 97.1053 plus 9.6525, substituting in the 5. And we are going to get, as a final answer, 145.367 calories. So if we're going to find the residual, we need to look at our our observed minus our predicted or expected value. And that then is going to be our observed value. It says was 140. Minus 145.3678. And you're going to get negative 5.3678. So that's tricky, right? The residual is about 5 calories, but unfortunately, there's a difference between 5 and negative 5. So we're going to choose E. That is false. The residual is negative, not positive. That was a lot of work for something we already knew. All right. Oh, well. Let's continue. All right, so we got a copy machine. You can read it. So we're given some values. We need to know what the slope is. And fortunately, we do have a formula for that. You guys have seen it in your book, the formula for slope. There's another place where you can find it, and I'm excited to finally unveil the formula sheet for the class. We haven't really had any use for it up until now, but I have included it in the class stream. So if you go over there, you can grab that PDF. It looks like this. So here we go. So really where we are so far on this formula sheet is we have looked at the mean, right? We do have the equation of a least squares regression line. This is how to calculate standard deviation. This is our the mean of all of our y values, which we don't really need right now. What we need is this one, because remember our slope is b. So let's go ahead and write that down and figure this thing out. So we get that our slope b, is equal to r correlation times the standard deviation of all of our y values divided by the standard deviation of all of our x values. So we've been given this information, fortunately, all right? So we got 0.86 is r. We have the standard deviation of y, and then the standard deviation of our x values. And then we'll put that in our calculator and see that we get 1.56. Alrighty then, nice. So, about what percent of the variation in the number of service calls is explained by the linear correlation between the number of service calls and number of machines? So what are they asking for here? They must be asking for r squared. Okay. They're looking for our coefficient of determination. We've been given an r value of 0.86. So if r equals 0.86, then r squared is equal to 0.86 squared, which it turns out is 0.55. 0.55. So we'll get 55%. Nice. It's moving right along. Go ahead and give this one a read. There's quite a bit going on here. Steeple length and steeple width for some tropical plant. Not even sure what that is, but anyways. So we've got two varieties, X and O. All right. Considering variety X only, there's a positive correlation, and we're looking for what's true now. True, maybe I should underline it so I don't try to do something else. All right, we're looking for which one is true. There is a positive, so looking at variety X only, which is, these are the O's and these are the X's over here. I would call that more of a star than an X, but you know, okay, all right, sure, why not? All right, so we're just looking at this data here, okay? There's a positive correlation. No. All right, that one's out. Deduction. Considering variety O only, the least squares regression line for predicting sepal length from it does not have a positive slope, right? That would be looking something like that. So that one's out. Considering both varieties together, there is a negative correlation. No. All right, hold up. You probably caught this. 0.86 squared is 0.73696. 0.7396, and thus we would choose C. Sorry about that. Coming back to this sepal length weirdness, combining both varieties together, there is a negative correlation between sepal length and width. Well, if we're to look at together, we would have to have a line that went through all of that. So then that would definitely have to have a positive correlation, right? All right, if we're considering them separately, there is a negative correlation. So it would be a negative correlation and a negative correlation. I like that one. Let's read E and see what we got. Considering both varieties together, the least squares regression line for predicting sepal length from sepal has a negative slope again. No, it's not. Okay, excellent. Let's choose D. All right, if we fit a least squares regression line to a set of data, what is true if a plot of the residual shows a curved pattern? Okay, what is true? And I'm going to just tell you right now, it means that a straight line is not good model for the data. All right, and that is all. That is all you can know about that. And that is actually what you're looking for, right? If you see a, right, if you do your residual plot, right, with 0 here, and you see this pattern, you know, that looks something like that, that's going to indicate that there is a nonlinear relationship between your explanatory and your response variables. Right. Mr. Nerdly, anyhow, he has some students in his AP Stat class. Let's see. We got grade point average and SAT math scores. So we've got a regression line. We've got the equation as well. What are we going to say is true about the circled point? The standard score for this student's GPA is positive. The standard score, it should not. It's below, right? Yeah, it's going to be below. So it's not going to be positive, right? If we were to look at a standardized value of GPA score, that would be below average, I believe, right? So that would give you, right, a standardized score, a Z value for that would wind up being negative since that point appears to be below the mean. So I'm going to say no. Let's see, if we use the least squared line to predict the student's SAT math score, we would make a prediction that is too low. No, our prediction would be too high, right? Because our prediction is up there. This student's residual is positive. Definitely is negative since it's below the line. All right, removing this data point would not change the correlation. No, it would definitely increase the correlation if we removed it, because that is a fairly extreme value. Let's just read this and make sure it's right. Removing this student's, oh yeah, it would decrease the slope. Yeah, because it is pulling the slope down, right? Pulling the slope down. Since it's below it, it's pulling the slope down. And if we were to get rid of it, our slope would increase. Awesome. All right, and just to reiterate, right, something that is down below here is dragging the slope down, right? This point right here is dragging the slope up because the least squares regression line is trying to minimize the distance between all of those points. So if this one is gone, then it's going to shift up. All right. We got some roller coasters. We have a computer output. We have a residual plot. All right. The circle point is a roller coaster in the Philippines whose maximum height is 70 feet. The observed speed of this roller coaster is closest to, okay, well, we're going to have to look at what this distance is, right? So what happened is, this is our predicted, and this is our observed. So our observed value was much higher than our predicted value. So we're going to have to find out what the predicted value is, and then we'll be able to add, I don't know, something like 11 to it. All right, let's find that predicted value. So y hat for a 70-foot roller coaster, if we've got our, so we need our least squares regression line, keeping in mind that our constant, this is our y-intercept. And then right over here, that's our slope. And we're not even going to deal with any of this stuff, right? None of that until later in the course. The only thing that we need currently are this and that and those values. So we're going to go ahead and use those values to write the least squares regression line. 21435x plus 28.174. All right, let's go ahead and plug 70 in there and get an answer. So in other words, we're going to go 21435 times 70 plus, oh my goodness, I'm running out of room, 21 point, we'll just round, okay, there we go. That is going to give us 43.1785. Beware. Don't just pick this number, right? We said we need to add 11 or so. I'm not sure, you know, where we're at right there. It looks like 11 to me. Maybe it's 12. Would probably make more sense for the answer. So let's go ahead and add 12. 43.1785 plus 12. And I'm talking about that distance right there. We're going to estimate it's 12 or 11, something. So we're going to get 55.1785. And we'll actually choose D. All right. I believe this is the last one. Which of the following best describes what S represents in this setting? So remember, S is your